Section 2.3 Equations with more than one variable. This section is just an extension of section 2.1 where we learned how to solve linear equations. If you recall in the previous section, in section 2.2, we had a formula for motion problems. If you recall, we had a formula that was this: rate is equal to distance over time. And we were able to rearrange this formula. Right now this formula solves for rate given the distance and the time, but we were able to rearrange this formula and rewrite it as follows by cross multiplying distance is equal to rate times time. So what this does right now is calculate the distance given the rate and the time. So there are times when we are given the distance and the rate and we want the formula in this form, but there are other times when we are given the rate and the time, then we want to have the formula in this form, and so on. So there's many instances in life, in sciences, in physics, chemistry, math, where you have a formula that calculates one thing, but you want to rearrange that formula to calculate something else. And that's what this section is really useful for, where we're given an equation with more than one variable and we want to rearrange that equation to solve for one of the variables that we are interested in out of the many variables that you have. Okay. So that's a motivation out here. We want to basically, just to recap, we want to rearrange the given equation. And the equation really, in essence, ends up being a formula, just so you guys know. Formula to solve for a different variable. That's what we want to achieve in this section. And everything that we learned in section 2.1 applies. If you recall, in section 2.1 when we were solving linear equation, our goal was what? To isolate all the terms that have the variable on one side, and then eventually just to isolate the variable itself. And that's what we want to do. The only thing to remember here is whatever variable we are trying to solve for, we just need to pay attention to that variable. Treat all the other variables in that problem as a number and just toss them around to the opposite side. Okay, so let's take a look at some examples first and then we'll move from there. Let's start with something simple. Let's say if I have 3x plus 2y is equal to 6. This is an equation, has an equality, has two variables. And let's say I ask you to solve for y. That means I want to solve for y, so we're only interested in the term that has y in it, the terms that have y in it, so you ignore everything else. So since I want to solve for y, I want to isolate that term. So I only have one term with y in it, so I'm going to isolate that, move the 3x to the opposite side. So we get 2y is equal to 6 minus 3x. And since the next step is to isolate y by itself, so you divide both sides by 2. So we get y is equal to 6 minus 3x over 2. So here is the equation solved for y. So now if you're given x, you can find y very easily. Okay, that's all we're doing. We're rearranging an equation to solve for one of the unknowns, one of the variables. Here's another example. If you have f is equal to 9/5 c plus 32. This is the classic formula that converts temperature. It's a temperature conversion formula that converts temperature from Celsius to Fahrenheit. So for example, if you're living in Canada, usually the temperature is all given in Celsius and you want to convert it to Fahrenheit, we would use this formula. Okay, but what if we want to do the other way around? What if you want to convert the temperature from Fahrenheit to Celsius? Okay, so our goal is we want to solve now for C. I want to rearrange this formula so I can find C given F. So let's do that. The first thing you notice in this problem is we have fractions and we have equality. So I need to get rid of those fractions. So I need to find the common denominator. So what's my common denominator for this problem? Just 5, because I only have one denominator. I'm going to multiply everything by 5. So I get 5 times f is equal to 5 times 9/5 c plus 5 times 32. Now there's other ways to do this problem, but I'm just trying to stick with the method that I showed you in section 2.1. So we get 5f is equal to, this will cancel here, 9c is equal to, plus 160. So now that we got rid of our fractions, we can easily isolate the variable that contains the term that contains c. So it's 9c. So let's move the 160 to the opposite side. We get 9c is equal to 5f minus 160. And then you divide everything by 9. So we get c is equal to 5f minus 160 divided by 9. Okay, and that's a fairly good formula, but if you want to clean it up a little bit, we can do that. If you notice there's a 5 common on the top, we can factor that out. We can write 9/5 times f minus 32. So here's your formula to convert from Fahrenheit to Celsius. If someone comes and gives you a temperature in Fahrenheit and they ask you for a temperature in Celsius, we can use that formula. Okay. Let's take a look at some more examples. Okay. Let's take a look at another easy one. This is the formula for the gravitational force acting on between two masses. So the gravitational force is equal to the gravitational constant m times little m divided by r squared. So you have a big mass here, you have a little mass here, and r is the distance between those two. So the gravitational force acting on those two objects is given by that formula. So I want to solve for m. Let's say I want to solve for g. Let's do that. Right now this formula calculates the force given all these other quantities on the right, but I want to do it the other way around. Given all the other quantities, I want to solve for g. Now clearly this is an equality in fraction, so I need to get rid of the fractions out here. This is over 1, so I can cross multiply and do it much more quicker. So you get f times r squared is equal to gm times m. Since I already isolated the term that has the variable I'm trying to solve for, I need to next get the variable by itself. That means I want to get rid of this. This is attached by multiplication, so I divide both sides by capital M, capital lowercase m. So I get fr squared over capital M lowercase m is equal to g. So there's your formula for g in terms of frmn little m. And so you can see how important these formulas are, this technique is, because there are many times when we want to rearrange certain formulas and we have to go through these steps. Okay. Alright, now let's take a look at another example. This is 1 over r is equal to 1 over r1 plus 1 over r2. This is a formula from physics when resistors are connected in parallel in an electrical circuit. So let's say I want to solve for r1. Right now this formula is solving for nothing. It's just a relationship between r, big R, little r, big R, r1 and r2. But let's say I want to solve for r1. So let's do that. Okay. First thing we notice again, fractions and equality. Get rid of the fractions. What's my common denominator? You take each factor to the highest power. There's a power of r1, r11, r21. So that's my common denominator, because each of the denominator just repeats once. So you multiply everything by the common denominator. And again, I do want to stress this. I know I repeat myself a lot. There's a reason for that. Sometimes repetition helps, but I want to there are many ways to do a lot of these problems that are faster. You might run into someone who might tell you, oh, you should do it this way, and that's perfectly fine. If you're comfortable, you understand it, and you're comfortable with it, that's fine. But when you're learning something new for the first time, it's always important to stick with a method again and again so it becomes a habit. And I'm trying to show you this method of how to get rid of the common denominator. How to get rid of the denominators whenever you're solving an equation with fractions. And we do that by multiplying by the common denominator. Out here, since this is over 1 and you're multiplying everything, we can cancel things from the bottom and the top. 1 times that is just r1, r2. Out here, r1's cancel. I get r and r2. Out here, r2's cancel. We get r and r1. Now this is a very interesting problem, so you need to pay attention. I want to solve for R1, so I want all the terms that have R1 on one side. There's an R1 term, there's an R1 term. So I'm going to move this to the opposite side. So it's a positive will become a negative. I get R1 times R2 minus R times R1 is equal to R times R2. Now, the next thing is we end up combining. If you recall, if I had a problem like this, for example, if I had 2x is equal to 8 minus 3x, how did we do that? We started by moving this to the opposite side. Let's make it a plus. So we get 2x minus 3x is equal to 8, which is exactly what we did here, because I wanted all the variables that I'm solving for on one side, variable terms on one side. Then we added these two together. So we ended up with minus x is equal to 8. So we divide by negative 1 because this is really 1. So we get x is equal to minus 8. You divide by minus 1 on both sides, and that's the answer. Now, if you recall, it was easy to do this problem because we had numbers to work with. Out here I'm solving for R1, but I don't have numbers to work with. I have these other variables in front. So how do I add them up? Well, we do it the same way we did this, except when we were doing this problem, we skipped a step in the middle, which is an important step that we need to pay attention to now. Okay, to go from this step to this step, what we really did is, if you recall, what we did is, if you notice, what's common in these two terms is an x common, so we took an x out. So we are left with 2 minus 3, and 2 minus 3 is minus 1. That's how we got that. But we don't do this step usually because it's a very trivial step, because we can do this in our head. 2 minus 3 is minus 1. But in this case, since we do not know what R2 and R are, we have to do this step. So if you look at this, in both of these terms, R1 is common, so I can take it out. I'm left with R2 minus R, and on the right I have R minus R2. So we combine these. Now this bracket R minus R2 minus R is attached to this R1 by multiplication. Our goal is to isolate R1, so we divide both sides by R2 minus R. So we get R1 is equal to R times R2 divided by R2 minus R. And there's your answer for that. Okay, so when you do these problems, if you cannot combine, if you're solving for a certain variable and you cannot combine the terms of that variable, then just factor that variable out, and then you'll get a nice chunk that you can divide both sides by. Okay, let's take a look at another example like that, very similar. Let's say I have y is equal to 2x minus 1 divided by 5 minus x. Now this equation calculates, or you can think of it as a formula. This formula calculates y given x. Okay, so for example, if x is 0, on the top we'll get 0 minus 1, and you get 5 minus 0, so you get negative 1 over 5. So y would be that. But what if I want to solve this for x? We want to solve for x. What if I want to come up with a formula for x given y? Okay, so let's do that. Now, so I want to solve for x, so I want to isolate, it's degree 1, so I want to isolate all the terms that have x in it. But before I can do that, I realize I have fractions. Anytime you have two fractions equal, we can cross multiply, so let's do that. Okay, so I cross multiplied here and here. The next thing we want to do is, anytime you're solving a linear equation, get rid of the parentheses and move all the variable terms on one side, the variable you're interested in. In this case it's x. So I'm going to first distribute and get rid of the parentheses. I get 5y minus yx is equal to 2x minus 1. Now I want all the x terms on one side. Now you have a choice here. Either you can move the x to the left or to the right. I'm going to move them to the right this time. It doesn't matter. Okay, if you do the algebra correctly, it'll all work out. So you get 5y, move the negative 1 to the left, so it'll become a plus 1. I have 2x here, move the negative yx to the right, it becomes a positive yx. Okay, the next thing I want to do is combine these two terms, because I want to collect all the terms that have my variable in it. And again, I cannot combine them because I don't know what y is. For example, if I told you y was 3, then I could combine it, because 2x plus 3x would be 5x. But since I don't know y, I'll do exactly what I did in the previous problem. I can take out a x, because there's an x common in both those terms. I get 2 plus y. So now I combine those two terms into one. This term 2 plus y is attached to this x by multiplication. Since I want to solve for x, I want to get rid of that 2 plus y. I do the opposite of multiplication, which is division. So I get 5y plus 1 divided by 2 plus y is equal to x. So there's my formula for x given y. So you can see it's not that difficult to do these problems. We're just extending the ideas from section 2.1. Just be careful of this step here. When you're trying to combine terms where you have variables in them and the variable you're solving for is also present, the best way to combine them is by factoring that out from those two terms. Okay? And that's pretty much it on how to do these problems. I can do one more problem just to kind of drive home the point. Okay, so let's go ahead and do that. Let's say that I have this one. I have v is equal to m times 1 over b minus ar over m. And I want to solve for b. Okay, so I want to solve for b. Alright, so let's do that. The first thing I notice, whenever I'm solving, if I have parentheses, let's get rid of them. So we get v is equal to mb minus, when I distribute here, the m times this term, m's will cancel, so you just get ar. Okay, so we're down to this, because when you multiply these two terms, m's will cancel, so you just get ar. Now I want to solve for b. Well, b happens to be in the denominator. I have fractions and equality, so I need to get rid of them. So I need to find the common denominator, which is just b. So let's multiply each term by b, so you get bv is equal to b times v is equal to b times m over b minus b times ar. I'm just multiplying each term by the common denominator to get rid of those fractions. Out here I just get bv. Out here the b's cancel, so we just get m minus abr. Since we're solving for b, I want all the terms that have a b in it on one side, so I'm going to move this to the left. So I get bv plus abr is equal to m. Well, I do not know what b is, I do not know what a is or r, so there's no way to combine these into one term, but I still want to solve for b. But I do notice that both these terms have a b in it, so I can factor that out. So I get v plus ar is equal to m, and then since the v plus ar is attached to b with multiplication, and I want to isolate just b by itself, I'm going to divide both sides by v plus ar. So I get b is equal to m divided by v plus ar, and there's your formula for b, given m, v, a, and r. So I hope this helps. It's an important topic that you do need to understand and be able to do for the future, where you rearrange problems, especially problems like this. You will see these later when we do inverse functions, so it's important to be able to do these problems. So make sure you practice some of the homework problems from this section so you can get good at it.